this map series will act as the one-stop solution for all your map queries, in which we will be looking at different continents, different parts of the world, and how map has played a very important role in shaping the present conditions. Some of the previous questions that were asked, like, why are world's fold mountains located at plate boundaries? A semi-molten layer called as asthenosphere, they constantly move on the surface of Earth. So you have this map of North America as a continent that stretches out from Arctic region and goes all the way till Central America. Important for exam is its distribution to the north of it. I find it very interesting. So now you can see how climate, how physiography, how soil, how vegetation gets integrated at one point. Actually, that is what you need to learn. Interrelation. Hello everyone, welcome to this new series that we are starting. We are bringing to all of you geography through maps. Now the purpose of this series that we are starting today is more like giving you an all-round picture of maps, which is very essential for your preparation overall. Maps play a very significant role when it comes to understand historical developments. As they say, history can be understood when we look better understood when we look it through maps. Same thing is with international relations. It is the map and international relations determine boundaries. And we are taking this step to bring to you this map series, which will provide a strong foundations for your preparation and will act as the one-stop solution for all your map queries, in which we will be looking at different continents, different parts of the world which are important India, for your preparation. In your prelims examination, questions are map based, as in which of the following countries is not the part of North Sea. Turkey is located between which of the following water bodies? Golan Heights is in which of the following continents? Now, these are some of the questions that have been asked in the past, and they need not necessarily be the places in news, but places which will always be important so far as the developments are concerned. They are always important, irrespective of whether they have been in news for last 1 year or not. They are geographically very significant places. I would call them as some of the hotspots, geographical hotspots. So, in this pursuit, the first continent that we are taking is North America. North America, if you look at your maps, world maps, North America is in the Western Hemisphere. It's one of the most dominant regions so far as the Western Hemisphere is concerned. And when we see the overall aspect of this continent, it looks positioned very appropriately to dominate the world scenarios. Like, it is located in between two big oceans. It has Atlantic Ocean to the eastern side of it. It has Pacific Ocean to the western side of it. At the same time, the location is challenging also. So, first we'll dig deeper into the physiographic aspects, physical aspects. We'll try to understand what are different physical features, how they have been formed, and we try to bring to you not just mountain ranges and rivers and lakes and etc. That is anyways to be done. But why this and how these mountains were formed? What is the significance of these rivers? What is significance of the coastline? How the geography of America has played a role in its neighborhood. How the locations, how physiographic features and geographical locations had played a role in its international relations, in its geopolitics. And how geography of USA played a role in American Civil War? Is there a geographical connection to it? Let's find out that. But before this, let's start with the physical maps, the physical detailing of North America. So, when we look at North America as a continent, so you have this map of North America as a continent that stretches out from Arctic region and goes all the way till Central America. As I mentioned earlier, the west of it lies North Pacific Ocean. To the eastern side of it is the Atlantic Ocean. But mind you, there are some more important places in here. Some water bodies like Sargasso Sea, like Caribbean Sea, like Gulf of Mexico, like Hudson Bay. And particularly when Arctic Ocean is melting because of continuous climate change, increase in temperature, it becomes very important for us to look at some of its features, islands that we see in the northern part of it. So, looking at the physiographic aspects of it, you will find that there are mountain ranges to the west of North America. We call them as Western Cordilleras. Western Cordilleras. Now, Cordillera term is a Spanish origin term. It has its Spanish roots, which actually signifies the mountain ranges that have been formed in different time periods, in different through different processes, and so on. A very generalized term. Not like folded mountains. Folded mountains is a very specific term. A block mountain is a very specific term. Likewise, volcanic mountain is a specific term which is specifying the origin of a mountain range. In a general connotation, Cordillera term can be used. So the Western Cordillera, you can see on the western part in your atlases, it includes regions like the mighty Rocky Mountains. It includes ranges like coastal range, coastal range. It includes a mountain range to the south of it called as Cascade Range. So these are different mountain ranges that we collectively use the term Cordilleras. And friends, you should be knowing, I'm sure you're aware that western part of North America, like California, Mexico, New Mexico region, these regions, Spanish is a language that a lot of people speak. Although most of the America is Anglo America, but there is a Spanish population that lived in the western part, Spanish speaking population in the western part. So there comes the term Cordillera. Okay, let's see Rocky Mountains. Now, I would consider Rocky Mountains, Rocky Mountains to be little mysterious. Like these are, suppose, the Rocky Mountains. These stretch from British Columbia region of Canada and go all the way till New Mexico region. So here, British Columbia region to the New Mexico region. Now, why is it so mysterious? Like most of the young fold mountains, Rocky Mountains or young fold mountains, most of these young fold mountains are located exactly at the plate margins, continental margins, like Andes. If you look at the location of Andes, it is exactly to the west of South America. But when it comes to Rocky Mountains, they are not exactly at a boundary line. They are not exactly at the margin of the continent, but little interiors. Here, not exactly at the margin of the North American plate. Now, what is a plate? Just a review. Plates are basically lithospheric fragments. Lithospheric fragments. Now, these lithospheric fragments are actually created because the lithosphere is brittle in nature. And since they lie on a paste-like layer, a gel-like layer, a semi-molten layer called as asthenosphere, they constantly move on the surface of Earth. They are continuously moving on this asthenosphere. Asthenosphere, asthenosphere acts as a facilitator. It acts as a lubricant, ensuring the mobility of these lithospheric fragments, to which we call them as plates. Now, these plates are mobilized, they are energized by convective currents generated deep inside the asthenosphere. Where does the energy come from? The energy comes from radioactive elements. The decay of radioactive elements generates heat, and because of which there are a lot of convective currents that are formed. Now, suppose we take an example of a lithospheric fragment. Let us presume this is a lithospheric fragment. These fragments are moved because of convective currents that are generated deep inside this layer of asthenosphere. What is providing them energy? As I mentioned earlier, it is the decay of radioactive elements. Now, wherever the energy comes from, it can create volcanic eruptions. It can create volcanic eruptions and can cause formation of ridges and cause the two fragments of the plate, two fragments of lithosphere to go away. Now, if it is moving away, that is diverging away, diverging from each other, it must lead to the convergence at the other end. It must lead to convergence at the other end. There's a simple point. If there's a divergence at one end, it must go and converge with something at the other end. Now, what happens here? At the point of convergence, some sediments which are present get kind of compressed, they get squeezed, and as a result, these tall fold mountains are formed. Okay, this is the process of formation of fold mountains. What happens here is that the Rocky Mountain is not exactly at the plate margin of North American plate. It is interior. Now, geologists explain that the formation of Rocky Mountains happened around 80 million to about 50 million years before present. That was a time when the formation of Rocky Mountains began. But it wasn't the same case as we have in other fold mountains. The North American fragment, North American plate at that time started moving westward due to opening of Atlantic Ocean. As it went westward, there is a there was a shallow oceanic plate called as Farallon plate. A shallow oceanic plate called as Farallon plate, which collided with North American plate, leading to the formation of fold mountains as we see in any other case. So all that you have to remember is convergence. But why is it slightly different? Is because as per the geologist, let's suppose this is North American plate and this is the Farallon plate. Farallon plate, because it is oceanic, okay, because it is oceanic, must be denser, So denser plate goes underneath, it goes below this continental plate, which are lighter due to composition, and some volcanic formations would have taken place. But later, this plate actually changed its angle of subduction. Instead of going this deep, instead of moving this deep, it changed its angle of subduction. It didn't go much deep, it goes horizontally. So, because the movement was slightly horizontal, here in the deeper parts, in the interiors of North American plate, granitic rocks were folded up. Granitic rocks were kind of compressed from below and they rose like the mountains that we have, Rocky Mountains. So, it's one of the rare sites, rare conditions that we have. Rare because most of them happen at the plate boundaries. It is slightly interior. So later, the Farallon plate compression led to the formation of what we today called as the Rocky Mountains, Young Fold Mountains. Okay. So now, what is important for exam? Important for exam is its distribution. Right? What is exam important for exam? If a question is asked about the mountain building, you can always mention that mountain building is taking place along the plate boundaries. Here is one example where it may not seem to be at exactly the plate margin now, but it is little interiors. It was a plate margin at one point of time. Let's go on to see another feature of North America. So here another mountain range. Okay. Here, another mountain range going to the west is the coastal range. You'll find coastal range exactly to the western part of Canada, British Columbian region, and goes till the Washington region of North America. This mountain range, coastal range, is largely sedimentary, in nature. But as it goes the southwards, you can see the continuation of it towards south. If you look at your atlases, right, looking at that, you will find that these coastal range is actually continuing little south of it and called as Cascade Range. Right, it's called as Cascade Range. So if you can look at your atlas and see this mountain range further southwards, Cascade Range. Little points, few more points on Cascade Range. Please remember that the Cascade Range lying to the west of it, west of North America, and to the south of Coastal Range, Cascade Range, the range actually is volcanic in origin. It has some volcanic peaks. Some of the volcanic peaks that we see in the Cascade Range includes Mount Rainier. So it becomes an important example of active volcano. It becomes an important reference. So please mark in your atlas Rainier, Mount Rainier. And this mountain Rainier is also the highest peak, highest volcanic peak of North America, Mount Rainier. There itself, there are few mountain peaks. Like here, western part, there is Mount Olympus. There's Mount Olympus, which is again an active volcano. Now, moving on further north in North America, moving on further north, in the northern side of it, there is this range referred as, called as Alaska Range. Alaska Range. Again, fold mountain range. Now, Alaska Range, observe carefully, it is very close to this Pacific plate boundary. So, from the Pacific plate boundary, as the movement happens towards north of it, as it happens to the north of it, few land masses, chunks of land masses got compressed and led to the formation of this range. So here it is because the Pacific plate is compressing northwards and there is a presence of North American plate further north up that gives rise to formation of Alaskan range. Now, what is important in Alaskan range? Here we have one mountain peak called as Mount McKinley, right? Mount McKinley. It is also the highest peak of North America. Highest peak of North America. What we mentioned earlier, Mount Rainier is the highest volcano and Mount McKinley is the highest peak of entire North America present in Alaska range. So it becomes important for us if we can mark in your atlas, see that location. Good, very good. If you have done so, excellent. Let's move on. So here we end our discussions of these mountain ranges to the west of it. Now, I want you to go a little south of it. As you move to the south of this the continent, you will find two mountain ranges in Mexico. One is called as Sierra Madre Oriental and Sierra Madre Occidental. Okay, so let me take it once more. We can take a rough sketch of North America. A rough sketch of North America. Here. So west of North America, west of Mexico, Sierra Madre Occidental. East of it, another mountain range, Sierra Madre Oriental. And in between these two is Mexican Plateau. In between these two is Mexican Plateau, or you can simply call it as Plateau of Mexico. Now, Mexican Plateau is very significant. Pay attention to this. It is one of the example of intermountain plateau. An example of intermountain plateau. What is an intermountain plateau? A table-like feature that is formed in between two mountain ranges. That's called as That's called as intermountain plateau. Okay, let's come back to this. When and where do we have the formation of this Mexican intermountain plateau? See, sometimes what happens when compressional forces, what happens is when compressional forces are active on both sides. Okay, they're active and almost equally compressing on both sides. In that case, there are two mountain ranges formed. We may call them as marginal ranges. And in between the marginal ranges, okay, in between the marginal ranges, there is a table-like land that rises up. So imagine we are compressing the two land masses from one side and at the marginal ranges, land masses rise. But because of that continuous compression, the land mass which is in between, it rises just like a table-like feature. That is called as intermountain plateau. Mexican plateau is one such example. We have few more examples in the world, like Iranian plateau is also an intermountain plateau. Then Tibetan plateau is again an intermountain plateau. So it happens usually in those regions where the marginal ranges are compressed to an extent and central landmass rises like a plateau, which is very important for silver production. So what is the significance of Mexican plateau? Remember, significant for silver production. Now, do we have young fold mountains all across North America? Yes, they are on the western part of North America, but as we move eastward, here there is another interesting feature. The mountain range is called as Appalachian Mountains. Okay, it's called as Appalachian Mountains. Appalachian Mountains. Now, what is the specialty of it? It's an old fold mountains. It's an old fold mountains. Now, again, it requires some bit of thought. What is an old fold mountain? Those mountains which were formed between Paleozoic era and Mesozoic era. Paleozoic era begins around 600 million years before present, and all those fold mountains which were formed between this Paleozoic and Mesozoic era, they are considered to be old fold mountains. And those which were formed in the tertiary period very recently, about 60 million years before present, and somewhere around that time, we call them as young fold mountains. Now, Appalachian being an old fold mountain was formed, Appalachian and old fold mountains were formed in Ordovician period. Was formed in Ordovician period. At least the formation began during this time. Because it is not at a plate boundary presently, it must have been at a plate boundary in the past. In Paleozoic time, it must have been at a plate boundary. As in, it is believed that all these continents, like today's North America, today's, you can say, Eurasia or European region, today's Africa, today's Africa, today's South America, all these were forming a chunk of land masses at one point of time, because they were formed together, they were compressing together. This happened around this Ordovician times. But then what existed prior to it? Were they separated? Yes, they were separated. They were joined again. Then there rises the question, do we mean that Pangea or supercontinent has been formed multiple times? Yes. The Pangea has never been the only one Pangea. There have been many Pangeas formed prior to the Pangea or the supercontinent what Wegener mentioned. So in your examination, you generally read about Wegener's theory, etc. But please do remember that there have been Pangeas which were formed even before 300 million years, what Wegener had said. We did have a Pangea prior to it, before that, and we will be having Pangeas in the future times as well. So during this previous Pangea formation, there were these land masses in between. But at one point of time in the geological history of Earth, there was a sea here, an ocean rather, called as Leptis Ocean. Leptis Ocean, which was in between present day Africa, present day Europe, present day South America, something of that sort. Because we do not know exactly what it would have looked like, but the suggestions are like this. Later, once they started converging and came to this this arrangement of continents, there was the compression in this Leptis Ocean, and that Leptis Ocean led to the formation of Appalachians. Led to the formation of Appalachians. Not just Appalachians, there must have been other ranges too. So do you think that there are other ranges also which were formed along with the formation of, along with Appalachians? Yes. Which were those? These were mountain ranges which is called as Caledonian Mountain, which is called as Hercynian Mountains. So contemporaries, you can treat them as contemporaries. That is Appalachians, Caledonians in the West Africa regions or Spanish region, and the Hercynian Mountains that is found in Ireland region. they were once formed, they were once together. So Appalachian is an outcome of convergence of or compression that we see in this ocean called as Leptis Ocean. Okay, this is how fold mountains can be thought of. Now, let's move on to one thing which is very interesting again. So, then another feature is to the north of it. I find it very interesting feature. And there are some geological geographical concepts which are important for your exam. Let's see that. To the north of Canada, here, north of this region, exactly to the north of this, northeast of North America, there is Laurentia region. You'll find a Laurentia plateau to the northeast of this continent, surrounding Hudson Bay. Now, what is this Laurentia plateau? It is the part of Canadian Shield. So, if you observe that carefully, you'll find it's written as Canadian Shield. Let's try to dig deeper into Canadian Shield. What is meant by shield? Why is it called a shield? And with this, you will automatically understand what is it important for. Okay, let's try to understand this. See, when early stages of Earth formation, continental formation, there were some rocks which were earliest to be formed. Let us suppose it is the Earth's surface, and on this Earth's surface there are few rocks that have got formed earlier. These earliest rock formations were further subjected to compression because of continuous formation of mountains, continuous formation of plateaus, or you can say sedimentation, etc. I'll use the term here layering. These rocks, which are deeper now, deeper rocks, these deeper rocks are called as cratonic rocks or simply cratons. Now, what are cratons? Cratons are rocks which were formed in the earliest phase of Earth's formation, evolution of crust, and these acted as nuclei for continental formation. We may call it as continental accretion. It is something like one of the sandstone you can imagine. Think of a sandstone. Sandstone has been formed by the collection of a lot of sand. Likewise, some rocks which are generally metallic in nature. I'll write down here. These are generally metallic in nature. Once they started solidifying, they started accumulating more and more of mass, more and more of rocks into it. So they acted as a central nuclei, they acted as a central point where other rocks started getting associated or joined with them. And the extent of the continent kept on increasing. We call that as continental accretion took place. But accretion has to happen around something that holds those rocks. Those rocks were held by this nuclei, which we call as cratonic nuclei, or simply we can use the cratons. They're very old, like 3 billion years old, or more than that, which we call as Precambrian or Hadean epoch, where they were formed, Hadean eon that were formed. Let's come to point now. The point that I want to make it here is that once there are layering that has happened, okay, layering that has happened, with time, if there is no new formation over it, if there is no plateau added over it, if there is no mountain range added over it, gradually erosional forces will show their power. Erosional forces will show their power. What is meant by erosional forces? Showing their power. Wind, water, glaciers, etc. They will flow over the surface. As these erosional forces act upon, the deeper rocks, which we call them as cratonic rocks. These cratonic rocks are rich in metals. Okay. When erosional forces act upon, if there is no new formation, upper layers get removed. Okay, upper layers are getting removed. Now, if the top layer gets removed, at some places the cratonic rocks get exposed. Those deeper rocks get exposed. These surfaces are called as shield. In simple terms, shield is the exposed surface of what do they expose? The deeper old ancient rocks, rather Precambrian rocks, we can say. Okay, now let's see. Now, question is, why do they? Why are they calling? Why do we call it as shield? Shield must be rich in metals. Why are they rich in metals? We understand that older rocks are there. Older rocks must be deeper. Metals have higher density. They must be present in the deeper layers. Okay, that's why we call the rich in metals. And they must be very hard. And usually they have this kind of formation, like slightly curved. So it looks like the shield of a warrior. Looks like the shield of a warrior. A warrior's the shields that they used was made up of metals, had very tough structure. This surface also has a hard rock, very tough structures, therefore called as shield. Now, all that the point that I wanted to make here is just one thing. Wherever you read the shield word, wherever whichever part of Earth's surface is the shield, it has rich metallic deposits. I presume we understood this concept, and now you should think on your own. Brazilian shield, what is it important for? Indian shield, what is it important for? European shield, what should it be important for? Now, Canadian shield is therefore important for metals. Like here, we find a lot of silver, we find a lot of nickel, we find a lot of zinc, we find a lot of lead. So it's primarily significant for silver and other metals as well. That is what we need to remember. Not in UPS exams, you need not remember every metal or every mineral that is found in a region, but a general description should be known for your understanding so that you can memorize this. And I believe that you cannot memorize everything. Please understand, you cannot memorize everything. Some things, some concepts, some factual informations you need to relate in your exam. You need to think. So if your conceptual clarity is strong enough, your map will be very good. You can easily understand maps. So as I mentioned earlier, purpose of this class is to use your geography concept on the surface of Earth. See how it is. And after these classes, we will try our level best that you don't have to look at any other source. Okay, you bring that geography comes to you through these maps. Okay, let's continue. So here it is Laurentia plate. Now let's go through these features once again. Western Cordilleras having Rocky Mountains, Cascade Range, Coastal Range, Alaska Range, McKinley Mountains, Mount Rainier, Mexican Plateau you should remember, Laurentia Plateau you should remember, and Shield part, why is it significant for metals? Then also the Appalachian Fold Mountains, Appalachians, what is the significance of it? We may see it otherwise, that Appalachians are well known for coal press formations. Okay, we'll relate that. Now, another very interesting feature, very striking feature in North America is Great Plains. They say that Great Plains of North America act as bread baskets of North America. They're very rich in wheat production, have prairie temperate grasslands called as prairies grasses. Let's see what is prairies, what are prairies, what do we get out of it, and how do these Great Plains become the bread baskets of North America. Let's see. I'll use this map that gives me a little more freedom to draw as I can. So please bear with these maps. Here we have Rocky Mountains. to the west of North America. As we mentioned, Appalachians. All right. Now, as we go to the northern side, our mid-latitude regions, westerlies dominate. What are westerlies? These are winds which actually flow from west to east for something called a subtropical high pressure to subpolar low pressure. Now, these westerly winds bring moist air masses, cause rainfall on the western slope of Rocky Mountains. Understandably so, mountains, if they collide, air masses may rise, cause rainfall, orographic rainfall we call it as. But at the same time, towards the eastern slope of Rocky Mountains, the conditions remain drier. These slopes, eastern side of the Rocky Mountains, act as these become rain shadow. They lie to the leeward side of it. So any mountain caused rain, orographic rain, air masses can cause rainfall to one side, but at the same time to the other side, rainfall cannot be caused because air cannot rise any further, and as a result, this remains rain shadow. Now, coming to the eastern slope of Rocky Mountains, here this region is actually the rain shadow, less rainfall region. So rainfall remains limited. Which part of North America? Eastern part of Rocky Mountains in the central plains. What is the effect of low rainfall? Less rainfall, that is, if it is between 40 to 60 centimeters or less than 60 centimeters, trees cannot survive, that forest cannot exist, because we need at least 60 centimeter of rainfall for the forest to survive. But here the rainfall is less. Now, since the rainfall is less, okay, the rainfall is less, here it gives rise to the formation of grasslands. It gives rise to the formation of grasslands. Obviously, when trees cannot survive, grasses. So we have this vast grasslands here called as prairie grasses. Prairie grasses, the central part of it. Let's begin. Let's try to develop the concept from here. Prairie regions. Now, since try to relate this, it goes all the way some part of Canada, like the Saskatchewan region, Manitoba region, Edmonton region, and the states, central states of USA, where these Great Plains are located. Right? Prairie grasslands. Let's put it this way. If temperature is less, this also means evaporation is less. If evaporation is less, this also means the soil moisture balance is positive. Soil moisture remains intact. Plus, the grasses which may decompose, they keep on adding to the organic content. They increase the organic content. So there is moisture, there is organic content. So what will happen to the fertility of soil? It increases. Organic content increases the fertility of soil. So these regions therefore become fertile regions. But if they are fertile, that means now we can cultivate. They can be important for cultivation. Understand one more point here. Which crop can be cultivated? Can we cultivate rice? No. Sugarcane? No, because they require high temperature. Here the temperature is slightly less. So one crop that is important here that can be cultivated is wheat. Wheat is semi-arid region. It is better grown in semi-arid regions where temperature is slightly lesser. So this entire region therefore becomes a wheat region, prairie regions. Right? I want you to also understand that particularly North America, there is this wind that blows in the same region. Think about the name of this region, this wind. So there's a local wind that blows in the same region, that enhances, that increases the fertility, that increases the chances of cultivation by melting the snow. That is locally also called as snow eater. I hope all of you got the name of the wind. It is Chinook. Okay, so now you can see how climate, how physiography, how soil, how vegetation gets integrated at one point. Actually, that is what you need to learn. Interrelation. So, Rocky Mountains, climatic conditions, wind system, soils, vegetation, all that leads to an economic system, that is cultivation of wheat, one of the economic activities in the region. Okay, that is how geography should be approached actually. Okay, let's go on to the next point. So, if agriculture is concerned, we have already reached up to the cultivation. Important is to look at the rivers as also. So, very importantly, rivers of North America, they have an excellent drainage pattern given by the nature. Nature has bestowed North America, particularly Canada, with so many lakes, so much of glaciation, so many lakes, and also rivers. First, we are looking at rivers of North America. Let's see the first river. In this region of North America, towards eastern side of the Great Plains, we have this massive river system called as Mississippi and Missouri River. Two river systems. We have Missouri, Missouri, and another river, Mississippi. Both form very important drainage systems. Looking at Missouri, Missouri originates from Rocky Mountains. Drains eastward, whereas Mississippi originates near lake regions, right? Lake Itasca is the origin point. From there, this river drains southwards and meets Missouri at St. Louis. At St. Louis, these two rivers actually join. And then the collective river drains into Gulf of Mexico. A lot of people keep asking this question in classes, which one is longer? Is Mississippi longer or Missouri longer? Both are having the same, almost the same length, but these kind of questions will not be asked in UPSC, and usually it is not asked. But even for our understanding or our memory, Missouri is slightly longer. It's like 100 miles longer than Mississippi, but most of them have the same kind of length. They're not very different from each other. The difference is not too high. So 100 miles difference. Missouri is slightly longer than Mississippi. Anyways, let's come to the southern point. At south, it forms a very weird sort of delta. I want you to look at this kind of delta here further southwards. Weird, probably unusual, if not weird. Very unusual sort of delta you can see here to the south of it. Now, this delta is called as bird foot delta. Such deltas are called as bird foot delta. It is one of the type of delta. So when you read deltas in your landforms, it is one of the example that we quote in types of deltas. So there are other types like arcuate delta, right, cuspate delta, right, truncated delta, like abandoned delta, and one of the delta is bird foot delta. What is in the bird foot delta? It looks like the claw of a bird. Pardon me if it doesn't look like a claw of a bird. Maybe I'll put some like this so that it gives a picture of a bird, claw of a bird. Now, usually rivers with greater volume have bird foot like deltas. It's a very unusual. Most of the deltas have arcuate shape. They are arc-shaped deltas. But here we have this bird foot delta, primarily because one of the main reason that we have is is the volume of this river. Huge volumes, and the braiding, breakdown of rivers or division of rivers happens way further into the oceans. It has got something to do with the density of the river and oceans. So deltas are usually formed in the regions where river meets the sea at the sea level. River meets the sea at the sea level. That means the difference shouldn't be there. The speed of the river is low, very less, right? It contains a lot of sedimentation. It has a long course so that it can bring a lot of sediments with it. And because it brings a lot of sediments with it, a massive landform is formed, which we call as delta. Here, volume is higher. Because of volume being higher, the bifurcation has happened within this, and we find this bird foot type delta. So, what is important for your exam? Bird foot delta. One of the example is Mississippi, Missouri. Why does it form? For your understanding, it should be there. Remember these places like St. Louis. Remember the origin points, because it is the largest drainage system in North America. Largest drainage system in North America. River number two, second river that we may look at is a river just to the east of it. You can see a river draining here called as River Tennessee. Okay. Next river, River Tennessee. Now, please understand, Tennessee River has some connection to our Damodar. What is that? Let's see that. Tennessee River actually goes from Appalachians and then joins a river, Ohio. And both of these, like, then Ohio drains in again into Gulf of Mexico. It drains again in Gulf of Mexico. Now, what is Tennessee known for? Tennessee Valley has rich coal deposits. Right? It has rich coal deposits. It's known for coal production. Okay. There's also one thing, that Tennessee drains through rift valleys. It drains through fault lines, and was flood prone. Okay. Was flood prone. Since it was flood prone, so many dams were constructed around this river. These dams were known for, they were used for hydroelectric power generation. These dams were also used for irrigation. These dams, or this project, was also used for navigation, that provided navigation facility as well. In short, in 1933, in 1933, Tennessee Valley Authority is one of the earliest multi-purpose projects. It is one of the earliest multi-purpose projects in world. Now, what is it to do with the Damodar? Damodar had the similar features. Damodar River in India is significant for coal. It passes through fault lines, was flood prone. So what we did, we developed projects, we developed dams across it called as Damodar Valley Corporation, incorporating 4 dams. Here there were 9 dams, around 9 dams here. Here there were 4 dams across Damodar region and its tributaries. Now it becomes India's multi-purpose project. which was based on Tennessee Valley Authority. So you can remember this DVC, Damodar Valley Corporation, DVC based on Tennessee Valley Corporation, DVC based on TVC. So in that context, you should be remembering the river, and very important for coal deposits in USA. Okay, let's go back. See another river. One river, just for the sake of interest, I'm mentioning it. There's one river here originating from Rocky Mountains and draining into Gulf of Mexico. It's called as Rio Grande. Okay, Rio Grande. The river Rio Grande, remember, originates from Rocky Mountains and then drains into Gulf of Mexico. It divides, the river divides Anglo America and Latin America. Latin America. To the north of Rio Grande is the English speaking America. To the south of it is the Latin speaking America. Politically, it forms boundary between Mexico and USA. So that way it should be important, it should be remembered that Rio Grande forms boundary between USA and Mexico. At one point of time, you can also say that it acted as a boundary between Latin speaking America and the Anglo America, English speaking America, originating from Rocky Mountains, draining into Gulf of Mexico. One more river is River Colorado. A lot of people remain confused with River Colorado. I get these questions over and again in exam in the classes that Colorado River. There are so many Colorado rivers. Here itself, you can see two Colorados. One is going towards Gulf of Mexico. There is one more Colorado in Argentina, right? Colorado. Now, which river should we remember? Remember the one that is flowing in western part of USA that originates in Rocky Mountains. Okay, so pay attention to this river also. Colorado, Colorado River. The river originates in Rocky Mountains, drains through Colorado Plateau, and finally into Gulf of California. Remember this Colorado. I mean, others are also Colorado, but suppose I get a question, I should not remain confused. I will be looking at, I will be marking it as the river that is in USA, originating from this Rocky Mountains and draining Gulf of Mexico. Now, Colorado River is unique in the sense. It fascinates me personally because a river that starts from Rocky Mountains, a whitewater river, very fast river. As soon as it passes Colorado, it suddenly shows rejuvenation. Now, friends, what is rejuvenation? Rejuvenation. Rejuvenation is coming back to its youthfulness. River starts eroding and shows a lot of meandering streams. So path of Colorado River is quite meandering. It meanders through the Colorado Plateau. And that happens because of some tectonic events that took place here. It is because of tectonic events that took place in the region. Okay, so this is Colorado region important for. One more. Let's find out some gold. Yes, that's how Americans put it in past. A lot of people had crossed this massive river in the northern side of it, called as Yukon River. Yukon River. Consider your atlases. Look at your atlas. The massive river that goes here, Yukon River. Yukon River originates near British Columbia. Okay, it originates near British Columbia, drains through the Alaska, and finally into Bering Sea. Okay, finally into Bering Sea. This river, when I say let's find out the gold, a lot of people had crossed this Yukon River to reach the city of Dawson. To reach the city of Dawson, where they search for the gold. So this Yukon Valley was therefore quite important because gold production and so on was near to this valley. So I want you to look at this map and mark Yukon River in Alaska. From the gold to industrial belt to a river that acted as a backbone of industrial development in USA. Which is that river? Is the river that drains to the northeastern part of USA and finally into New York Bay. Name is Hudson River. Okay, so it needs a special attention. Although the river is not mighty, it's not a mighty flowing river like Mississippi or any other river, you're not even Colorado. So here, this Hudson River moves and drains into New York Bay. Now, if you see these five sisters together, Superior, Michigan, Huron, Erie, Ontario, we look at these lakes later. So, it passes through the Great Lake regions and drains into New York, plays a very significant role in inland water transportation. Inland water transportation facility. So industries are benefited. A lot of trade happened through this Hudson River. So this becomes important. So in your atlases, please mark River Hudson. What River Hudson does for USA, there's one more river exactly to the north of it, St. Lawrence River. The river St. Lawrence does for Canada. St. Lawrence River originates near Lake Ontario and drains in this gulf called as Gulf of St. Lawrence. Provides the facility for inland water transportation. That way, these rivers are important. So I want you to look at these rivers once again. Okay, suggestion is that these facts, this conceptual understanding will not stay with you just by one reading. Read it multiple times. Read it 3 times, 4 times, revise it. Then only you will start remembering these things, these factual informations as well as understanding of concept. So I believe if you understand, good, very good. It's the first step. Afterwards, you need to develop your memory. How do you do it? Revise the concept multiple times over and again so that your understanding in that concept translates into deeper understanding and interrelation with other concepts. So memorize these facts. Let's see that once again. The question is, at the beginning of this discussion, I said that has geography played any role in shaping the American Civil War? Or for that matter, has geography played a role in determining or shaping the political arena, political shape of North America? The answer is yes, but the question is how? This detail in the next discussion, in the next episode of this series. So I'll see you there with a discussion on other features and its geopolitical phenomena. Thank you.
For more informative content, like, share and subscribe, and do not forget to press the bell icon to get the notifications.